Hey guys, this is going to be a very short video. Over the course of the past couple of years that I've been writing Python language, I thought I learned a lot, and I thought I should share some of these experiences with you, because you could gain a lot of benefits from knowing some of these subjects early on and where to look and where to find them. So basically, I'm going to talk about a couple of things about sort of like best practices to write Python programming, in Python programming and writing Python programs. A lot of these concepts apply to all programming languages. Anytime you want to write a program in sort of like any programming language, these are the stuff that you really have to know and look up and to write better applications and be more efficient. So without wasting any time, let's talk about a couple of these. Python programming language, the Python has a very good documentation online. Make sure you go there. It's searchable through Google. Just find it, docspython.org. Pick the version that you're running on. I'm not specifically talking about Python for Revit, just for anything. In IronPython, we're on the 2.7 version, 2.77, which is the IronPython implementation. It's a little bit behind in terms of its specifications. But for any version of Python, you can find the actual documentation here. One of the best and most useful pages is the Python standard library page. These are the stuff that I suggest to anybody that's learning Python from just starting learning Python. Make sure that you go through the built-in functions. Any good Python programmer knows all these functions by heart, because these are super important. They're generally written in the C programming language in terms of Python, in the native programming language for that Python engine. In terms of IronPython, it's IronPython. So they're a lot faster than anything else that you might, or the functions that you might find yourself writing. There are a lot of amazing built-in functions in there. Like for example, let's talk about filtering some numbers. Let's say I have this set of numbers, and I can use the built-in filter function, filter method basically, or function, and I can give it a sort of like a lambda function, which is I'm basically describing that the filter reads the numbers from the number list, passes it to the lambda function, and I'm checking them if they're bigger or larger or equal to 5, and then filtering the data based on this. So you see, in one line of code, you are doing the filtering that you need to using one of the built-in functions. Obviously, you have to be careful about using this on a large number of objects, especially if you're dealing with Revit elements, because those objects take a lot of memory. Just taking each one of them and applying a function to them could take a long time and stuff like that. So if you can do the filtering inside Revit, do that, but just understand what these built-in functions are. A lot of them, like for example, the function like sorted can accept also another lambda function that sort of like explains the sorting logic to it. The reverse, there are a lot of a lot of these functions are super useful. Make sure while you're learning Python language, you learn all these functions. Please, they're super helpful. There's a very good documentation on it. You can see anything that's going on here. A lot of these stuff you might forget over time if you don't use it as much, but they're very powerful, and they're used across the sort of like all the modules and third-party modules and anything that you see, code from other people that you download from internet. You can see how many of these have actually been used inside the code. So another one of the part in Python standard library is that it talks about, as you know, Python comes shipped with a lot of libraries for doing different things. Two of the most important ones that I like to point to is the collections module and the itertools module. These are make sure you generally take a look at a lot of this stuff. There's so many useful things in there. Like for example, if you're dealing with CSV, there's a module that for reading and writing CSV files. It's super useful if you're just using CSV format to store or read data in whatever table system that you have and stuff like this. So a lot of these stuff are super useful. As an example, let's talk about the collections. Let's say you want to create a class that let's say you want to create a class that represents a point. And I'll talk about the object-oriented programming a little further. But let's say you want to talk about, let's actually do that. So um, I'm sort of like trying to tie these two subjects into each other at this point. There is a lot of you have experiences writing object-oriented programming in languages like C# or VB.NET and stuff like that. These languages are explicitly object-oriented programming. You can't just go inside a C# script and define a function just out of the blue. It has to belong to a parent object. There are methods. You don't have functions in C#. A lot of people have different opinions on these two subjects. What I'm sharing with you here is just my personal preferences. And I like the way that Python has been designed, and I kind of follow that system. So Python allows you to write functional, sort of like functional programming languages. Like say you can just define any function to get point or whatever here. And then this would be a function. It doesn't belong to any object or anything like that. Or you can define a class that represents a point and provide like some functionality as methods in here. Imagine that. You could do either of these. The parent concept to all this is namespaces. This is extremely important for you to understand what namespaces are. And I'm going to show you one Python module that I just finished recently, sort of like as an example. So, creating modules in Python is very simple, and I urge you to learn how to do it. They're extremely simple. You just basically at the lowest point, you just have a bunch of Python scripts together in one folder, and that becomes sort of like a module. Like this module that I've written is to interact with Revit server, and to basically get the information on the server, list the files, and stuff like this. So I've created different namespaces for myself, and let's talk about what is a namespace. Let's say you import a lot of you. Let's say as an example, if you're writing Python programs for a while now, you understand, what the OS module is. Let's say you import OS path. This path is an object that is inside the OS module. It's inside this namespace. What does it do? Namespaces create a space for you to have unique names. And we might have talked about this before, but so what does it do? Let's say, so if I want to create OS path, and I have another variable here that's called path, OS path and path are different from each other. Why? Because this path lives inside my module's namespace, and OS path lives inside OS's namespace. So namespaces are a way for you to separate different functionality, different names from each other. So I can define, but let's say I created two modules, module 1 and my function, let's say whatever that does. And then I have created another module that I'm importing both of them here. And I've basically defined the same function into, well, two functions with the same name in two different modules. But you see that because they belong to a different namespace, this is fine. I can keep using them here as, in their own namespace. But if I say from module 1 import my func, and same thing with this, then I don't have the names, then I'm not benefiting from that namespace. I'm importing that function from the module namespace into my own namespace. So what I'm effectively doing by writing the second line, I'm overwriting the first input, because you can't have two equal names in the same namespace. So the second line really replaces that function from the module 1. This is a very bad type of import. Don't do this with any module. Like, don't do import like from OS import path. This is a bad way of doing it. Like you see in this module, I have a server namespace, and I have a models namespace, and I have an exception and stuff like that. But when I'm going inside the server and I need some of this stuff from API or models, I'm importing them like this. You can shorten the name if you need to, you can from rpws, which is the module models, import that as model. So I don't have to write this whole thing every time I want to use any of these objects, but I'm using it, bringing the whole namespace inside here. So later when I want to use any of this stuff that's inside that namespace, I can just type models file info, or models anything else, models log state, models folder info, anything that lives inside this module. This is, I'm also, obviously I'm very quickly touching on these subjects, but just understand the concept of namespaces. You have to whenever you're writing an application, break it up into different sort of like more generic components of that task, and then separate those namespaces from each other. This gives you the benefit of being able to reuse some of these components in other tasks that sort of like need similar functionality and things like that. And obviously, it helps your code to be a lot more readable. Like for example, this file is about 1,050 lines of code. Well, with the documentation, but imagine if I wanted to import all this information about the models and all this information about the exceptions and all this API in one simple script. That would be extremely hard to traverse through and read. So this helps with the readability of your module as well. Now, going back to the subject of object-oriented programming, a lot of people, when they learn about object-oriented programming, they get excited and they're like, "Oh my God, this is amazing! I can create an object and I can put all these methods under it, and it's perfect." So what I'm trying to tell you here, that you can look at a class, an object, as a namespace, right? So if you have a bunch of functionality that belongs to points, you could do a class like this and put all your methods in here, or you can just create a module that counts. It's a Python script basically that's part of your bigger module that is named points, and they're just functions inside that point and inside that method. Know and understand why we create classes. Class is a data type. So just like as you say, like I don't know. Number equals 10, and the data type for number is an int, is an integer. By defining classes, you're defining new data types. Data types are created to hold data in them. The beauty of classes is that it gives you a system to provide functionality that belongs to that specific data type. For example, if you have a string, well, let's see, name equals, so that's my name. You can say name.lower. So see, all these methods are methods that belong to that string data type class. This is very nice. You can work on the data that is stored inside that instance with one of these methods. This is a very, very good feature, but be very careful about how much you're using this. The right way to do it is to, before actually write a single line of code, take a piece of paper and write down your the data, the schema of the data that you're trying to interact with. Let's say it's a point in a 3D space, and understand what you're trying to do with it. Like for example, if I am writing in a script to read a series of points from Revit's database and print the XYZ of those points, and I'm not really doing any operations on those points, creating a class that represents a point would be a little bit of waste of space. Why? Because classes are data types, and the programming language, the Python engine, has to allocate more memory for this sort of a creation of this data type. This means that you are wasting a lot of memory for creating things that you're not using them for their whole purpose. You're not creating, like for example, I can say find point, and I can do the init function, and I can say self, x, y, and z, and then be happy that I can go later. Let's say I'll finish this, but be happy that I can go later and say point, and say 1, I don't know, 0, 0, 0, whatever. Define a point like this. This is very elegant. There's no doubt about this. But if you're not using the full functionality of this class, maybe there are other better ways to do it. Like for example, one of the standard data types in Python is a tuple. You can just use it as this, reference this point in a space as a tuple. This is a lot more efficient than defining a class. Like say you can say point equals that, and then the way you access the x variable would be the point 0. And I don't know if you like it to see the defined, I don't know, do something on the point, like transform a point, and then you pass a point tuple to it, and you want to access the x, y, z, and then this is not elegant enough for you, and you don't like this because you have to write this down every time you're using x. Well, there are better ways to do it. Know your language. X, y, z equals point tuple. You can do that in Python. It would expand these three values into these three variables. And because this function has its own small scope in here, this is fine. You can just use that and do your mathematics in here and return it as another tuple. So see, depending on the functionality that you expect and the operations that you want to do on that data type and the features that you want, you have to decide which one of these, which data type is correct for that. If you can go with the built-in data type, please do that. They're so much faster than anything else. But if you can't absolutely do anything about it, well, create your own data type using a class and provide functionality to it. Remember that object-oriented programming can get very complex. Don't commit to it for everything. Don't try to write everything in an object-oriented manner. My personal preference is that whenever I'm defining a class, defining a data type for a thing like a point, as just to use it as another example, I would only write methods under this that only operate on that object itself, not operating on anything else outside that object, because that way you're not really benefiting from this object-oriented and subclassing system and stuff like this. So try to keep everything that's inside that class function only on the data that's inside that class. Because remember, you are beyond everything else, you're defining a new data type. So all the functionality and methods that are on that data type should operate on the information inside that data type, not anything else. I'm going to use this as an example in here. Well, this is a module that, as I said, I created for interacting with the server. I decided in this case it'd be nice to define a Revit server class. Why? Because then the user can go in and say Revit server equals Revit server, instantiate an instance of that Revit server class in a variable, and then use all this functionality that comes as part of this class to basically talk to the server and interact with the server. So I've created one class for this, right? I could have created this as a namespace. I could have created a server and put all these functions inside the namespace. But the challenge with this is that all these functions need some basic information to be able to operate, and that's for example, the base URL to be able to talk to the Revit version, and the Revit name, this Revit server name, and the Revit server version to be able to grab the link and stuff like that. So if I had designed this in a sort of like a module system and provided all these functions in the root of that module without any classes, then every time you wanted to use one of these methods, you have to provide the Revit server name and the Revit server version to be able to work on that, and that's inconvenient. This is a nice way of doing it. You can create an object that it gets initialized once, and it would retain this information in its memory, and then all the other methods can use that information to be able to interact with it, so the user don't have to provide all that information every time. A lot of people say that object-oriented helps with code reusability. That's not exactly true. I understand that you can provide a simple method like this inside an object that all these other methods are using, and this is nice because you write this method once, but you could do the same thing inside a module space. You can define a private function, for example, for yourself inside the module, and do other functions, other public function that uses your private function to do its tasks. So all your public functions could technically use a private function to do their job. This is also visible to the user, but is a common practice in Python to start private variables and methods and objects basically with an underscore. So good Python programmers understand that, oh, this is private, I'm not supposed to use this, use the public ones, and everything. You're still reusing your code beautifully. So before you jump into making everything object oriented, just make sure that you understand what you're doing with your objects. If you have how many of those objects you're going to create, how much memory you're trying to use, and things like that. This will immensely help you to write more efficient programs, and also helps you later, 6 months down the road, when you're looking at your code again, to basically understand the structure a lot better. A lot of these stuff are explained in the Python standard library. Make sure one of the most important things in the Python standard library is actually it's in the documentation. If you go under language reference, make sure you read this section on data model. So this explains how Python is constructing these classes and stuff like that. Like this is the place that Python explains. Let's say if I can find. So this is the place that Python documentation explains what a dunder iter method is. This is one of the standard methods that you could define under your data type, which is going to be a class that you're defining, to make it an iterable object. These are extremely powerful. So make sure you just take a look at this, and it's a lot to digest. You won't be able to learn this like on day one. There's a lot of this stuff that I haven't used, and I'm still yet to learn. But it's just good for you to just maybe at least read the top part of this, understand what's going on, and how Python is sort of like treating its objects. This is a very important section, so if you have time, please read that. I'm gonna go back to the library reference. So we talked about. I also pointed out to the collections module and pointed out to the iter tools module. These have a lot of tools that help you with iterating over different sets of objects and stuff like that. And the collection, like for example, in terms of when we're talking about the point, you can do from import collections from the collections module. You can import. Actually, I'm going to do this because from import collections, import named tuple. This is a specific type of tuple, so I can say point equals name tuple. I'm going to call it point. Make sure these two names match, because it would be very confusing if you don't do that. And then say it needs to have x, y, z. And then later, so this will automate the different definition of a class for you for the point. But the main thing about tuples is that, and this is one of the things that you really should understand, the difference between mutable and immutable objects in your programming language. Tuple is an immutable object, or mutable. I'm not. I forgot the English translation for it. Let's look it up. Immutable objects cannot. Okay, so an immutable object is an object whose state cannot be modified after it's created. Sorry for the confusion. That happens when the English is your second language. So what this means is that if I define a point as like this, 1, 2, if I define a tuple like this, later I can't do s0 equals 12 to change this value to 12 instead of 1, because it's an immutable object. You can't change that. The benefit of this type of object is that it uses a lot less memory, because it knows that it won't be changed after that. So if you're just grabbing a bunch of points from Revit and using them somewhere else without ever doing any functionality on this, don't define a class for a point. Just use a tuple. It's so much nicer. And you can create, with the name tuples, you can create a point like this, for example, with 1, 2, 3, for example, and then say px or py, referring to the properties that you have defined over here. So it's a nice way of doing this. So look into these modules. There's so many powerful things in just the built-in features. You don't have to even download anything. As long as you're Python, the built-in standard library has so many powerful tools in it. We talked about the object-oriented programming. We talked about the standard modules. I urge you to learn how to create your modules also as well. And one of the other things that I want to talk to you about very quickly is the concept of exceptions. Also go into their standard library and look up for error handling. I'm not sure if I'm in the right place for this. Go into the tutorial and go to the section that talks about errors and exceptions. Learn how to handle errors and raise errors in your programming language. A lot of functions, like for example, if you're trying to do this, it raises an exception, and exceptions are objects and they have types and stuff like that, so you can easily and very accurately track them. Understand how to use try and except, and understand how to use them in a loop and things like this. So, like for example, in this case, you can try this code, and if it returned any errors, and if that error was IO error, you can do this thing, and if it was a different error, you can do this thing, and if it wasn't any of these, you can do something else and raise it back up. Learn how to handle errors and raise errors. And then when you're when you're creating your own module like this, go ahead and create an exceptions namespace or script for yourself, so you can define new types of exceptions that you are returning. This way, the user that's looking at your module has a better understanding. Instead of just being a generic exception, it has a better understanding of what error has been raised and what caused the error. Like for example, in this case, on my module, I'm raising a server version not supported exception. If the user tries to initialize my Revit server object with a version that does not belong to the sort of like the database of links that I have in here. It's not supported. So if version is not in that, I'm raising an exception of server version not supported. When the user runs this code, they get this exception, and then they'll be able to see it very nicely in their Python Revit environment or whatever. Whenever they're running their code, they would see that as a result printed in the console, and they would see, oh, okay, so that's an exception. That version wasn't supported. They don't really have to dig into your documentation to be able to figure out what's going on and blah blah. So understand this concept is very, very important. Handling exceptions and raising exceptions. And please, above everything else, I've been told this by another friend of mine, and I started doing it, and I really learned the value of this. Please document your code. It could take a while for you to do it. I know it's hard to do. My personal preference is that as I'm writing the code, I do like short documentations like this, short comments like this, that I know I can look it up later and then expand it into a better documentation. But first of all, if you're doing it in Python, take a look at this Google Docstring system that is sort of like a convention that Google has for creating document strings in a Python script. Like for example, if there's a function, this is the sort of like the convention to document that function inside the using the Google Docstring convention. You're not installing or using any specific tools. This is just how you write this text in here. So you say, the first line is one-liner about what function does, and then you can talk more about it, and then you list the arguments. You say what each argument is of whatever type, and you explain what that parameter is for. And then you'd say what type of data it returns, and if you have to provide links to other articles about this and stuff like that, you can do it. Same thing with the classes. There's an example on how to document classes and other types of data types and stuff like that. This is super handy. Like for example, I've documented my Revit server here. Right after the class definition, I am telling that what does this class do, what the arguments are, what the attributes of this class are, and as a just an example, for the user to be able to see how they can use it. So for example, even if I'm in my own code and I'm saying, Revit server, see, my auto-completion already pulls the documentation from there and it explains it to me. So imagine you are the user of this module later. By just typing and opening this, the auto-completion tool will provide the documentation for that class for you right in front of you. There's everything here: arguments, attributes, even an example. A lot of times, what I'd really like to do as well is that if there's a method that raises, like for example, this init, there's a lot of things. Wait, hold on. Like for example, this one. If your method raises exceptions, make sure you create a raises section 2, and you talk about the exceptions that this and the errors that this your method could raise. It helps in the documentation for the person to know why this exception has been raised and things like that. So there's very nice ways of doing it. Like for example, and you're not limited to these titles. You can do almost anything you want. For example, I am, let's say, get drive info. Yes, like for example, in this function, I'm creating my own 2 sections in here explaining what command I'm using from Revit's RESTful API and what keys I'm grabbing from the dictionary to create that data type that's the drive information on the server. And I'm providing an example here. I'm telling what type of data I'm returning with the correct namespaces. So I'm saying it's RBWS model server drive info. So it's very easy for the person that's reading this to understand what's going on. The extremely nice thing about these document strings is that, and specifically Python, is that Python can return these document strings in values belonging to those methods. So then you could build tools. That generate like HTML documentation for you. Like for example, this is the Revit, the RPWS, which is the Python wrapper for Revit Server RESTful API that we were just talking about. So I've created, I'm using Sphinx, which is a tool to create sort of like auto-generate documentation. I've auto-generated documentation for this Revit server and I've posted them online. So I can see all this information are nicely listed here with examples and everything else. I didn't go in and create all these HTML files and the website and everything else. The only thing that I did is that I documented my code in here. So it has a lot of benefits, and later on, whenever I come back and read this, I would be able to understand what's going on a lot easier. A lot of times, if you're in a more professional sort of like Python programming environment, like for example PyCharm even can understand all these examples. It can read your data types from the let's say in these examples, can even read these data types, and later if you're using this method and providing the wrong data type, it'll actually be able to notify you that, oh, this expects a function object in here and you're providing a string or whatever. So it's a great skill and practice to be able to document your code nicely. Like for example, for this module, when I finished just writing the code, it was about 700 lines. But now you can see I've added another 300 lines of just documentation to it. But you can see the benefits of this. The last thing that I want to talk about, there are 3 quick things that I also want to talk about. One is that understand Unicode, right? Look up online and understand what Unicode is, because a lot of times there are people from other countries and other languages that are using your code, and if you're not Unicode aware, if you're using the strings just in normal ANSI manner and stuff like that, it could potentially break. Python is really good at capturing this kind of confusion into its own strings and things like that. But just generally take a look at this and understand what's going on. It's a very important thing for other people to be able to use your software without having any troubles for that. For example, I get a lot of questions on pyRevit because initially I didn't really pay attention to the Unicode part, and then there are some people in Germany or in Russia or in other countries that had like folders with Russian characters in them or different types of characters in them, and then my pyRevit would break on them because it wouldn't understand that there's a Unicode inside Unicode character inside that string, and I wasn't handling it properly and stuff like that. So just be aware of that. Be aware of that concept. One of the other modules that I really want to point out to you, which I've already closed that, I think. let's go back to the documentation and the standard library. When you are getting a little bit better in the with Python later on, go to the standard library and take a look at the threading and multiprocessing modules. These are very powerful. Threading and multiprocessing is not a hard thing in Python to do. It's a lot simpler than any other language that you have seen before. Let me give you an example. Let's say you have you want to create a script that downloads a list of 10 websites. So you have a list of 10 websites. You can write a function that says download a website, and you pass the website link to it, and I'm just writing passing here, but imagine that that's downloading the websites, and I'm just gonna say websites equals a list of all these strings to the links to that website. Let's say there are 10 of them, and you can write a script that iterates through this. It says for website in websites, download the website. The problem with this is that let's say the first website takes 10 minutes to download. Your script is going to be hung here for 10 minutes until the first website gets downloaded, and then it moves on to the second one. Well, there's a much better way to do this, and we have been using this multi-threading system and multiprocessing system for ages. The whole operating system that you're sitting on is multiprocessing, and the only reason that it can run multiple applications at the same time is just because of that. So it's kind of silly that we're not using them as easy in our scripts and programs. Using the multiprocessing module in Python, you can create a process for each one of these downloads, launch all these processes at the same time, and basically the longest time for any of these processes that takes for it to finish would be the runtime of your application. So if like all the websites get downloaded in 1 minute and one of them downloads in 2 minutes, the whole application will finish its job in almost 2 minutes. The way to calculate it's not an exact science like this. It's not as simple as this, but your application is gonna be a lot faster than just running it like this. Especially if you're waiting for I/O input/output from like websites or files and stuff like that. And then let's say, as another example, let's say you have a list of objects in Revit that you have acquired. Let's call it, I don't know, walls. And you want to find 3 different wall types in it. So you have a list of types of the wall types, let's call it 1, 2, 3. So imagine you have like 1,000 objects in this. And you want to find 3 different things in this. So you're going to say, type 1 equals a list, and then type 2 equals a list, and type 3 equals a list. Let's say you want to do this, and you say for wall in walls, if wall.type, for example, equals that, oh, actually, I'm sorry. So you could do 2 ways. So you can say for wall type in wall types, so grab one of the wall types and then go iterate through all walls. If that's the wall type number 1, let's do this, append. I'm not writing the best application in here. I'm just writing something to sort of like, tell you how this thing works. So let's say you want to find these 3 different types in the walls. So you go through each one of them, iterate over 1,000 walls, grab those, and put them in a list. But the thing is that you already, while you're iterating over this, you can grab the 3 of them at the same time. You can check for 3 of them at the same time. A lot of times you can just do this logic in here. So if I know I only have 3 of them in here, I can just write just like that. I can get rid of that piece and say if that's the case, if let's say equals type 1 or type 2. I know I might be a little confusing you, but let's just get rid of those. So you could do this, right? You could do this, but this means that you have built in and baked your logic inside your script, so it only works on 3 types. What if you have like 5 different types? So one of the ways to do this is that if you learn how to do multi-threading, you can create as many threads as you have wall types, and each one of those threads can go over the list of walls and find the ones that are basically that match that type. So potentially, in the time that it takes you to iterate over 1,000 walls, you can collect all the different wall types and put them in the put them in different lists. So imagine like working, if you have a tool that works on 1,000 or 100,000 objects in Revit, how much faster it would be instead of waiting, going through all the objects, grab the first type, go through all the objects again, grab the second type, go through all the objects again, grab the third type. You can see how much faster your scripts could be. So please, when you got better at Python programming and kind of feel comfortable with like going a little bit deeper, please go and understand the multi-threading and multiprocessing modules and how to use them. They're super simple. They're not that difficult, and I urge you to use that. We talked about Unicode. We talked about multi-threading. There's this thing called PEP, which are Python enhancement proposals. This has been going on for years, since the Python's creation. People create proposals to make some part of Python better, and they post this to Python community and the Python Foundation that protects and creates Python and stuff like that. And it would get voted between people, and all the users are involved, and everybody votes on them. And if it gets accepted, it gets posted as a PEP with a number. This is one of the very first PEPs that's been posted as part of the Python enhancement proposal. It's very famous as PEP8. Style Guide for Python Code. Make sure whenever you have time, just as a casual reading, look through this document. It tells you the best practices for writing clean, readable Python code. So it tells you how to do this, for example. If you're having too many variables that are passing to a function and they don't fit in your line, you can break it and tap the line so they're aligned kind of nicely like this, and it's readable. Everybody that looks at this understands that all these four are part of the same function call. So there are a lot of like this, even like naming the variables and how to comment and how to create lists, and you can see there's so many different subjects in this, and it's a very famous PEP. So take your time, take a look at this. It's a very good thing. The last thing I want to talk about is the PEP20, which we talked about PEPs. PEP number 20 is the Zen of Python. Take a look at this. Beautiful is better than ugly. Explicit is better than implicit. So explicit, if you use your namespace explicitly, or if you define a type explicitly, or assign a variable explicitly, it's better than being implicit, because when somebody is reading your code, they can easily see it, and it's much better to understand. Simple is better than complex. Be as simple as you can. But if you can't be that simple, well, then complex is better than complicated. So don't be complicated. At least complex is better than complicated. Flat is better than nested. Don't create too much nesting in your modules and stuff like that. I actually sat down the first time I wrote this module. I created all these different types of classes and objects for every entry and stuff like that. And I realized after 2 weeks of not looking at my code and then going back to the code, I realized I don't even understand my code anymore. So I just rewrote the whole thing to be just simple. One server object that interacts with everything, and then proper simpler namespaces for the data types, and I'm using name tuples for this because I don't have classes. This information that's coming from the server back to the user is not going to be changed, so I'm using a name tuple for this, or enums. So a lot of things, you get the point. So read through this. Some of these are very important. See, the namespaces are so important that if it's even included in the Zen of Python. Last thing, if you want to have easy access to this when you're inside your Python console or whatever, just import this, and then that is your it actually prints out. Oh, it's not doing it anymore. Anyway, so when you import this, you can actually do it here, I think. Let's do Python and say import this. Oh, so it actually prints out the Zen of Python for you. Easy access. Take a look at this. It answers a lot of your questions. If you're confusing yourself when you're designing your module or anything like that, it's super helpful. I'm going to leave it at this. These are sort of like my best practices to work with Python. These are the stuff that I generally keep in mind whenever I'm working on a module, and I hope you find this useful.